So you're ready to solve case one. And what you've got here is DNA profiles or DNA that's been isolated from genes of 6 different poached elephants, plus a profile of this ivory that was seized from the crime scene, so to speak. And so your goal is to find an exact match, which means that any gene we look at, which we are using this word marker, so any gene we look at, we should have an exact match for the alleles of the mystery elephant, the tusk DNA, and the elephants here. So I'm going to show you how I would go through this, and what I would do is I would go one at a time. Let's look at marker FH71, okay? So here's mystery elephant, and it looks like he's only got one band, which means he's homozygous at that marker, or he has 2 alleles with the same number of STRs. Elephant candidate 1 is also homozygous, but look, his band falls at a different place on the gel. It looks like his gene is shorter. It traveled further than mystery elephant. So even though they're both homozygous, this isn't a match. So he's out. Elephant 2 looks like that's a match at this gene, so he could potentially still be in. Now, elephant 3. Elephant 3 is interesting because elephant 3 is heterozygous, right? Because elephant 3 has 2 different alleles, meaning that this allele here on the bottom traveled farther and it's got a smaller number of repeats than this allele, so inherited different alleles from mom and dad, and one of them matches. But if it was the elephant whose ivory was taken here in the sample, then it would also be homozygous like him. It would only have one band at this location. So number 3 is out too. So far 2's our only candidate. This one is way off. This is a way longer, way higher number of repeats. And then we've got 2 more. This one looks like a match if we track over. It's about 70 base pairs, right? The same as our mystery elephant and number 2. And this is also not going to be a match because this fragment is definitely longer. It has more STRs. And we know that because it's falling below where the band of the mystery elephant is. Okay. So we've got 2 options so far. We've got 2 and we've got 5 that could be an option. So I'm going to actually close up that marker and I'm going to look at another marker. And I'm just going to keep in my mind that 2 and 5 are possibilities. Oh boy, this is going to take some close looking. So mystery elephant now, is he homozygous or heterozygous? Quiz yourself. Homozygous, right? Because only one band of DNA, which means both of his alleles, have the same number of STRs. Now, elephant 1 is a match for marker FH19, but could that be the elephant where this ivory was taken from? The answer is no, because if I look down at the first marker, that one didn't match. So every single gene or every single marker has to be a match, okay? So elephant 1 was already out, even though he matches here. It's a really important point. I'm going to close marker 1 again. Elephant 2, actually I'm opening it back up. Elephant 2 was a match before, but now when I add this marker, FH19, elephant 2 is heterozygous and doesn't match elephant 1. So elephant 2 is out now, so my only hope is elephant 5, and let's check to see if he matches. Does that look like a match to you? Looks like we've got one allele homozygous for 190 base pairs. It falls between 180 and 200 in our mystery elephant. And we have one allele in elephant 5 that falls between 180 and 200. So that looks like a match to me. So I'm going to click him for the moment just to kind of keep that in my head. And the reason I jumped right to 5 was, remember that he was the only other one besides 2 that matched at our first marker. So what I'm going to do now actually is I'm going to close both of these markers. He'll stay clicked, and I want to check the other genes because if he's truly a match, every single gene should match between the mystery sample and this elephant 5. So let's check here. Is he a match with the mystery elephant? Mystery elephant? Uh-oh, looks like mystery elephant is heterozygous for FH127, this third marker. And is elephant 5 heterozygous? No. So I don't even need to look at the fourth marker to know that there is no match among these elephants. Now remember, before I move on, you might be looking at elephant 1 again and going, wait a second, elephant 1 matches mystery elephant at this third marker. But remember, he didn't match at the first marker. And if it really was the same individual, all of the DNA, any gene we look at, any marker, we would see a perfect match. So I don't think there is a match. I'm going to check myself. That's correct, right? So there was not an elephant that matched at every single marker. So they're going to give me a few more options, right? So we're going to do the same thing again. I challenge you to try this yourself if you haven't already, now that you've seen how I did it. I'm going to keep working through, but if you think that you can check elephants 7 through 12 on your own, try it yourself, right? And then use my video if you need it, but stop here if you think you can do it on your own. You just got to go to case 1, finding a match, and work through it, okay? Now, let's see what I can do. Let's look at our first marker for these elephants. I've got a homozygous result in a mystery elephant, which matches elephant 7 and elephant 10. But notice that 8, 9, and 12 are all heterozygous. They have 2 different versions of that gene, so they're out. And 11 is homozygous, but it's definitely not at the same location as my mystery elephant, okay? This is a shorter fragment of DNA because look, it traveled farther. It's closer to the 60 base pair line. So far 7 and 10 are my only candidates. I'm going to open up the next marker and let's see. We had 7. That doesn't look like a match anymore. They're both homozygous, but elephant 7 has a longer DNA strand. It didn't move as far as the mystery elephant. So 7 is out. Let's see if 10 does look like a match. So this is the same location, roughly 190 base pairs. So I'm going to click that, and then I do need to check these other markers. So let's close that so we don't get confused. Let's see if elephant 10 is a match. So we've got a heterozygous result for mystery elephant, just on either side of the 160 base pair line. And look, heterozygous, just on either side of the, this is looking promising. Okay, so the first 3 markers are a match. I'm going to close that one up. And here is our 4th marker. Does elephant 10 match? So this is our 4th marker right here. We've got a heterozygous result at about 100 and, 90. And we're going to go look at elephant 10. That looks like a match to me, right? Now, again, remember, so elephant 8 is also a match here, but elephant 8 didn't match at this marker. Let's see, it didn't match at this marker. So even though elephant 8 is a match here, we have to match at every single marker, and it looks like elephant 10 does. Let's just review it really quick. Here's a match on our 4th marker. You look at our 3rd marker, and that's the same as our mystery elephant. Our 2nd marker, and that's the same. We got like 190 base pairs as our mystery elephant. And on the 1st marker, we had a homozygous, about 70 base pair allele, and that's the same. So I'm going to go ahead and say that number 10 does match the mystery elephant, where we harvested the DNA from the tusks. And look, we're right, okay? So the ivory profile of 10 does match. And so you have now seen how to solve this case, and what I want you to do is continue on to case 2. And we're not going to worry about this frequency primer thing. So if you are looking at this and you're like, what do I do with that? Just skip over it. It's a cool idea. It basically just explains that we can think about how frequently each allele would happen to decide, would there be another elephant that matches at all these markers? But it's a little bit of complicated math, so we're going to leave that for now. So just go ahead and move on to case 2. Again, read all the background. When you see blurbs of text, watch all the little videos and see if you can solve case 2 now. You're on your way, all right?